All right, welcome back everyone. Today we're going to talk about the second problem set. We're going to walk through all the answers together. So most of them I'll insert clips of utilizing Excel or how we can complete parts of them with Excel, but most of them can be easily completed by hand. So this is the second problem set and this is macro. All right. This problem set covered chapters 10 to 16, which are the ones that the exam will focus on. The exam will really only go to chapters 19 or so and a little bit of 20, but we'll focus on the first question. The first question was centered around chapter 10, which focused on international trade and capital flows. So in this one, we had two countries. We had Canada and Mexico, and both of them traded in electric cars and solar panels. So we're gonna say cars and solar panels. Canada with this is the total number of labor hours. So when we talked about capital flows, we talked about labor hours and competition-wise and whether or not economies of scale, so bigger economies have an advantage over other economies. And what we focused on here is whether or not there would be an absolute advantage or comparative advantage between these two. Absolute, think like the best advantage. And we can say comparative, thinking like trade-wise. If one country is better at producing one thing than the other country is, then they're going to specialize in it. So in this case, Canada was able to make 20 labor hours to produce one car. So it takes 20 labor hours to produce one car in Canada, and it takes 12 labor hours to produce one single car in Mexico. And then for solar panels, it takes 10 labor hours to produce one solar panel, and it takes 6 hours in Mexico to produce one solar panel. So remember, this is labor hours per one unit of good. So again, per one unit. So it takes 20 hours to make a car in Canada, it takes 12 hours to make a car in Mexico, and vice versa. So the first problem asked us to identify whether or not there was a country that has an absolute advantage. So part one, right? Or yeah, this one asks if there was an absolute advantage. To figure out if there was an absolute advantage, we have to figure out who uses fewer labor hours. In this case, right off the bat, we can say that per car, we compare 20 to 12. Well, obviously, the one that has fewer hours is 12. If we want to compare the panels or solar panels, well, in Canada, it takes 10 hours to make one. In Mexico, it takes 6. 6 is smaller than 10, 12 is smaller than 20. So who has the absolute advantage? It would be Mexico. Remember again, we're trying to figure out an absolute advantage, who has the best advantage, who can make things the fastest with the least amount of labor hours possible. In this case, it's Mexico. The next question asks us about the opportunity cost. Opportunity cost has to do with the opportunity to produce one thing given you give up another, or so on and so forth, right? Opportunity cost of school is whatever you forego in potential wages or anything else you've lost out on. So we need to find out the opportunity cost. So opportunity cost can be calculated by this way. So OC is going to be a ratio, and a ratio is where we compare two things. And a lot of times we use ratios as like a division problem. You might also see them like this, side by side, like this and this. That's another kind of ratio. We're just comparing one thing to another. So in this case, it's the labor hours of good A versus the labor hours of good B. Labor hours good A, labor hours good B. So in this case, let's call the good A and good B. All right, if we want to talk about in Canada first. Mexico. In Canada, if we want to say their opportunity cost of producing a single car compared to the opportunity or the labor hours of a single solar panel, that's 20 over 10. 20 divided by 10 is 2. So for every one solar panel you can produce half of a car, and vice versa, right? So that would be like this. So if I made a car, I could produce 2 solar panels in that same amount of time. We're doing a comparison. What do I have to give up of one to produce of another? So in Canada, I can produce 2 solar panels per car, and I can produce 1/2 of a car per solar panel. Now, if I do the same thing in Mexico, if I do the same ratio, 12 over 6, right? 12 labor hours for a car, 6 for a solar panel. That means I have a similar thing. I can produce 2 solar panels per car. And then I flop this around. Well, same kind of thing. 12 over 6 is still 1/2. And so I can produce 1/2 a car per solar panel. And those are my opportunity costs of each. The last question then asks us, given all this information we have, which country should specialize? Well, it takes Canada a little bit more time to produce things, but the opportunity cost of one thing versus another is still the same. So both countries have that identical opportunity cost, right? This is the same as this is the same as that. So neither country has a comparative advantage when it comes to labor hours, but there is some kind of benefit in the amount of resources that they allocate. So if the question comes down to, do either of these countries have a comparative advantage? Well, if we're just looking at the opportunity cost of production, no. And in this case, would trade be likely? Not really. But we can rationalize and think more of it, right? Just because there's no specialization gain. So neither country in this case would want to specialize in either item because the opportunity costs are exactly the same. Mexico is able to produce things quicker than Canada does. So there might be some benefit in that way. The next chapter, chapter 11, focuses on aggregate supply and aggregate demand. And remember, these are kind of like the combinations of all the other ones we focused on, right? Our goods market, our price and our quantity, our labor market, our wage and our quantity of labor, and our finance market where we talked about interest rates and we talked about borrowing or how much people are borrowing. This is all those things together. So we get to look at unemployment, and we get to look at how inflation works, and we get to look at those pressures and talk about long run and short run. So the first question on here asks us to plot these curves and find the equilibrium. So remember, equilibrium is where aggregate supply equals aggregate demand. That's where those two things cross. Equilibrium is always where things cross with each other. In this case, we can super easily identify where equilibrium is because where these two things meet is right on here. So we can already say, without even having to do anything, that our equilibrium is going to be at a price level of 130. And this is our GDP measure, right? This is how big or our economy's scale is going to be at that GDP level, or where aggregate demand and aggregate supply are at 580. So if we remember equilibrium, that means we should also be able to remember when we graph something like this, it is going to be where our two lines cross. So we don't have to be super specific with our graph. Big thing, demand, that downward slope, right? Our aggregate demand stays the same. The one thing we'll notice, and if you plot these ones out perfectly, is that supply is going to have that kind of Keynesian flatness, and then it's going to get steeper as we hit more of a neoclassical. But they're going to cross exactly at our equilibrium. And our equilibrium is at a price level of 130 and then 580. Remember, we can call this output, we can call this GDP, anything we want. And then this is our price level. That's our first question satisfied. Our next question talks about, would we think that there would be some kind of high unemployment or low unemployment in this kind of economy? And then what kind of inflationary pressures are we going to end up happening? So traditionally, what we've looked at in class is when we have something like this, we would also have somewhere our potential, right? We would have potential, or we would have potential GDP, or we would have our long run aggregate supply, and we would call this just our short run aggregate supply. How close our equilibrium would help us to be able to tell, but we can also tell what's going on in the economy based on where it is on our short run, or where our equilibrium sits. So in the case, what we have here is that our equilibrium is sitting on kind of like our flatter Keynesian portion, and because it's sitting on that Keynesian portion, see this flatter portion here, this is like our Keynesian part here. If it was over here, that's our intermediate, and remember this here is like our neoclassical. Since it's sitting at this lower portion of our thing, and it is, if we can visualize a potential, it's a little further away from maybe potential, but since it's sitting at that portion, we are actually going to experience some unemployment. We aren't super on this higher portion where we would be higher or more towards like potential, or where we're using everything and all our resources. So we are a little bit lower on this flatter portion. So we would have some unemployment. It might be a little higher. Wouldn't be absolutely crazy though. Because the economy is not using all its resources here. That's a big thing. If it's not using its resources, it's not utilizing all the laborers. It's not towards its kind of natural resting rate. And then also because we are on this flatter portion, the third question asks us about inflation. Well, inflationary pressures at this lower portion and our flatter one are minor. They're minor there. We don't have this super big trade-off between price and output. We're not super close to what we might consider to be some kind of potential. In this case, I have an example potential on here. We'll say potential potential GDP is like at 620. So our long run potential was say at 620. Well, our equilibrium is a little further away, but they were not super worried, right? Since we're not utilizing everything, there is no pressure on prices.
Here we go. If we want to be able to do the problem on aggregate supply and demand, it's going to be pretty simple. So we want to make sure we have the table copied and pasted. This one, we have our price level, we have our aggregate demand, and we have our aggregate supply, and our goal is to create something that looks a little bit like this. This one here has this added piece of potential GDP in, but we would just want to go into insert, then we want to go to chart, go to scatter, and then the easiest way to do this is to right click on this chart, go to select data, and we're going to press add. Our first series is going to be our aggregate demand, so we're just going to click on the cell for that, and it'll automatically name it. Then we're going to drag down just our values of X. Our values of X are our GDP in the dollar amount. And then for Y, we're going to drag down the price level because that represents our Y value and or the price level in our economy. Then we're going to add our series in for aggregate supply. Our Y values are again our GDP, and then our X values are our X values are our GDP and our Y values are our price level. We press OK, and then these are going to pop on up. One thing we're going to notice is it's not going to be perfectly centered. So the thing we want to do next is we want to fix these axes. We're going to right click on it. We're going to click Format Axis. When you're doing this in the desktop mode, you're going to do it pretty similarly. Then we're going to go to minimum and set a minimum. For this one, I'm going to say a minimum about 450. We can go a little bit higher if we want to, but I think this is good enough to be able to see everything. Maybe even if you want to go to 475, that works too. And then we're going to click over on our y-axis and click format access again. And then over on this side, we're probably going to do about 100 as our minimum. That way we're going to see everything. Now we can see our slope a little bit better. We can see that our equilibrium is on this flatter portion of our slope, what we might consider our Keynesian portion. And then last, we need to make sure we are accurately doing our axes titles and labeling everything. So this is an aggregate supply and demand model. And then our y-axis or our vertical axis is our price level, or it's the price level in our entire economy. And then our x-axis is, in fact, our GDP, or if we want to call this output, it's our output. And that's all you need to do. If you wanted to add this in, you would add this in as a third line.
Chapter 13 or chapter 12 focused on our Keynesian perspective. So that was that flatter portion of our short run supply curve. And one of the big things we focus on in the Keynesian model is we talk about the multiplier, or in this case, it is the expenditure, or how much government spending can make more and what kind of ripple effects it has. So in this question, we says the expenditure multiplier shows the initial change in spending, which leads to a change in GDP. So if government spends something, well, their spending is going to become other people's spending, which will become other people's spending, and so on and so on. And then it'll build on itself. This is the multiplier that we looked at. We said it is 1 over 1 minus the marginal propensity to consume. MPC, marginal propensity to consume. The marginal propensity to consume tells us how much money in an economy are people willing to spend themselves, right? A higher marginal propensity to consume means that if somebody gets their wages, they are more likely to spend a huge portion of it. A lower marginal propensity to consume means that consumers are less likely to spend their money, and they are more likely to sit on their money and just kind of wait with it. So this question says that the government of Malaria is launching a new infrastructure project, and it's worth about $2 billion. The marginal propensity to consume is 0.8. So we have spending, in this case, is 2 billion, and the MPC, our marginal propensity to consume, is 0.8. We're going to plug these on in. So for question 1, it is just a plug and go. So we have 1 over 1 minus 0.8. That's going to be 1 over 0.2 and or 5. So this means that whatever spending we're going to see from an economy should give us about 5 times as much back. And so the next one is asking us to calculate the resulting GDP growth. The change in GDP is represented by change in Y. Remember, Y is like our output, that's our GDP. So a change in GDP is going to be the multiplier times the spending. In this case, we have our change is going to be that 5 times the $200 billion. What does that mean? Well, 5 times 200, 5 times that is 1,000. $1,000 billion is really just 1 trillion. So that means that GDP increased by $1 trillion from that spending. The next one asks us, well, what happens if our marginal propensity to consume falls? So what if something happens, people aren't as willing to spend, maybe the economy doesn't seem to be as doing well, consumer preferences might have changed, maybe just overall there's a little bit of turmoil for the future, people just don't know what's going on, so they're not going to spend as much. So what if the MPC goes to 0.6? Well, the first thing we're going to do is we're going to talk about the change, right? We're going to plug it back into that equation. That equals 1 minus 0.6 that equals 1 over 0.4, or our new multiplier is going to be 2.5. So we can see that it drastically fell, right? So before, people would, whatever was pumped into the economy would get about 5 times the amount of boost. Now it's only really going to get 2.5. So if we calculate out what this difference is going to make, we have to do the second one again to change the multiplier. So our multiplier 2.5 times whatever we're spending, which is that $2 billion. 2.5 times 200 is about 5 billion. And so all we're getting back now is 5 billion. We're getting back about half, a half or so of what we got back before. So why does this happen? So how do we explain the multiplier, and how does it work if we have a recession? So in this case, right, if consumer are changing, and if our marginal propensity to consume is falling, we're probably seeing that consumers are not as secure in our marketplace and something's happening, right? Something bad, things are falling, they're going in the opposite. How does this work in an opposite? So if we kept going, right, marginal propensity kept falling and falling and falling, well, during a recession, that happens. So during a recession, we see a decrease in spending. Right? A decrease in spending also means we have a decrease in somebody's income, right? Because your spending is somebody else's wages. Your spending is somebody else's income. And then what we're going to see is that because of this, it's going to become a nasty cycle of less spending, less income, less spending, less income, less spending, less income. And so this can create what's called a negative multiplier effect. The next one talks about our next chapter, and our next question is about our chapter 13, and this is the neoclassical perspective. So we had Keynesian perspective and we have neoclassical, and these kind of came together into what our intermediate, or like our interpretation of a little bit of both of them. So in this one, we focus on something called the Phillips curve. So if you remember, the Phillips curve is like this relationship that we saw in the 70s, where when inflation and unemployment were kind of doing opposite to each other. Just like we have opposites in our like downward sloping demand, if anything has a downward slope, that means that they are doing opposite things. If one's going up, the other's going down. If the other's going down, the other's going up. So in this case, it tells us that an economist is studying the United States. They're collecting some employment data and some inflation data. This is all in rates, by the way. I just didn't draw it all out. And it's telling us we're collecting this data, and we need to first draw and plot out this stuff. I'm going to draw a really simple version of it. It's going to look a little bit crazy. It looks something like this. It has a downward slope. Oh, it's not perfect. It looks something like this. And then inflation is on one axis, and unemployment is on the other. We have unemployment on here, and we have inflation here. So it's asking us to plot this. This looks a little crazy, right? That's because realistic data, and one thing we figured out in that chapter was that this Phillips curve like this applied in a certain period of time, but it is not always the case. It's not a hard, fast rule that because inflation is going up, unemployment is going down. And that's one thing we are currently seeing, is that now in 2026, we have both inflation increasing and unemployment is increasing. And so it's hard to do some policy tools that we would normally do. And so this question is asking us what kind of relationship we're seeing here. This is a general inverse relationship. Inverse relationships are those downward slopes. So we can say for the first question, this is an inverse. So if one goes up, the other goes down, right? An inverse relationship between unemployment. If we kind of take out some of these outliers, we see that downwards relationship between them. This would suggest, right, when unemployment is low, inflation is high, and if inflation is low, unemployment is high. And then this would tell us a little bit that we have a little bit of our Phillips curve here. Hello. So we have a little bit of our Phillips curve. Our Phillips curve is like that traditional downward. So it's not perfect, but it's there. We see it a little bit. And then based on this data, we also want to figure out our third question. This was the second one. That's the first one. Our third question is just asking us briefly, what do we think our natural rate of unemployment would be? Remember, our natural rate is kind of where our economy wants to sit at. where it naturally rests on our cycles. Because we have cycles. We have people who transition between jobs. We have people who are moved out of industries and into new industries. We have people that have just take a little bit of a break and then move back in. There's always some kind of unemployment. There's always people, like younger people, who are entering into a marketplace, and it just takes time. And so in this case, we can see unemployment, and what we want to look for really is what numbers repeat. So I see a 4, I see a 4, I see a 4, and I see a 4. And given all my data, I can say that the natural rate in this economy is going to be about 4%. Does that make sense? Traditionally, 4% isn't a super bad unemployment rate. That's kind of that like cycler what we've seen. And in that case, we can also see during that points 2, 2, 1, and then 5. We can say it naturally for inflation too, given those points. Inflation sits 1-ish, 2-ish with a little bit of an outlier of 5 at the end.
Goal for this one is to be able to create a graph that looks a little bit like this. So first thing we want to make sure is we have all our columns. So the interesting part about this is, remember, to plot something we need an X and a Y value. In this case, all of our dots are just years, so we don't actually need that value in our graph unless we'd like to plot each point with a label. So we're going to go in, we're going to go to insert, and we're going to insert in our handy scatter. So we're going to go in, insert in our scatter, and then what we need to do is we're not looking at trends over time. We are looking at a comparison of unemployment rate to inflation rates in a given year. And so we're going to go to selected data. And we can call this year if we really want to. It doesn't matter what we name this one. And then what we need is our inflation rate is going to be our X values. And our Y values are going to be our unemployment rate. We can press OK, OK, and then it'll pop up like there. Next, I want to make sure everything is labeled properly, right? So United States inflation and unemployment. 19, and then I'm just going to put in the years. Remember, this is random data, but given the context of the question, we're going to put in a correct title for it. And then what we want to do is we want to make sure we're adding labels. Our axes are labeled properly. We're going to label this an inflation rate. We're going to label this other one a nice unemployment rate. And there we go. We have something a little bit like this. Now we could go in and label each one of these, add a label and add a custom label. And the custom label, we could do it for each year, so we could see the relationship between years, but that's not necessary. This is perfectly fine.
All right, and then chapter 6, one I think is a little bit more fun and realistic. It's one that I think that people actually, especially if you travel anywhere, you have to understand. You have to know what your money's worth in other places. And chapter 16 is where we really started to talk about exchange rates. Right, what is the money worth? How does the dollar, our USD, stand in other countries? What we kind of learned is that the US dollar is a really strong dollar. There are a lot of other countries that use or utilize. Stock market is really popular with that kind of USD. And in this question, we say that we're going to assume $1 or 1 USD is equal to about 120 yen. Later, something happens. So we start first here, and we move to here. Later, something happens, and 1 USD ends up being equal to 130 yen. What we first need to figure out is whether or not, and the first question asks us, did the US dollar appreciate or depreciate? So does it gain value or lose value relative to the yen? So Q1 asks us that. Well, so before, with 1 US dollar, I could get 120. And if I want to create a ratio, that might help me too. So I could say, right, just like we did with opportunity costs, where we did a ratio of 1 over the other, we could do the same thing here. So 1 over 120 is about 0.0083, and 1/130 is about 0.0076. So we can already see for $1 to 1 yen, in that case would be the comparison, $1 is going to buy more originally than it did in our second case. So our dollar buys more yen, and because the dollar has, so our dollar buys more yen, and that means it's gained value, aka it's appreciated. Right, the dollar has gained value, it's appreciated. It used to buy 120, now it buys 130. We do a comparison of one versus the other. $1 to 20 yen, that means about 0.3, and it lost, right? It got smaller. Yen depreciated. Yen depreciated, dollar appreciated, gained value. So if the second question now asks us what happens to trade if we have something like this. So if we have trade and US goods, if US goods can now buy more money and the US has appreciated, that means it's going to be more expensive to import US goods. So in this case, have gone up in price. US goods have gone up in price. That means we are going to export less. Right? The more expensive a good is to the outside or the other country, the less they are going to import that good, and that means the less we are going to export. And so in the opposite case, right, that means the yen, since the yen got cheaper, or goods in Japan are now cheaper, so Japanese goods went down in price. That means people are going to import more, right? US goods become more expensive. People don't want to import those, so we're going to export less. Japanese goods become cheaper. That means the price is cheaper. We are going to import more of those, and they are going to export more. So the last question says to us, if we have a Japanese car, we have a Japanese car. Their car costs $2,600,000 yen. We need to figure out what price in US dollars it was before and after the exchange rate. All we gotta do is divide. Oops. So originally, it was a 1 to 120 ratio, and now it is different. It's a 1 to 130 ratio. We're just going to divide the cost, the total cost in yen of the car, by what 1 yen gets you a US dollar. So originally, this car cost $21,667, and now it costs only $20,000.